This is Problem Solved, the IISE podcast, where we talk to industrial and systems engineers about their work, ideas, and solutions.
Hi, everyone. Welcome to Problem Solved, the IISE podcast. I'm Casey Spansel, an IISE member and a quality manager for advanced cutting solutions in New Orleans, Louisiana. The COVID-19 pandemic produced many challenges for the healthcare system in the U.S., one of which is tracking key pieces of life-saving equipment as patients flooded hospitals. Nandhaguru, also known as Guru Durai, an engineering student at Louisiana State University, worked with industrial engineer Milad Amini at Our Lady of the Lake Regional Medical Center to create a tracking system for CPAP and BiPAP machines that created efficiencies in locating the machines across the hospital campus. In this episode of the podcast, Guru, Milad, and I will be discussing how the project came about and the benefits it created for the Baton Rouge Hospital. Milad and Guru, welcome and thank you for joining us today. Let's start by going into more detail with Milad's background and the work he has been doing with LSU's Industrial Engineering Department over the past few years.
Thank you for having me, Casey. I'm Milad Amini. I have a bachelor's and a master's degree in industrial engineering. I joined Our Lady of the Lake Hospital after finishing my master's at LSU in summer 2017. Our Lady of the Lake is an 800-bed hospital based in Baton Rouge, Louisiana, with more than 7,500 employees. As an industrial engineer in the Lean department, I have worked on several hospital initiatives, including patient safety, supply chain, patient satisfaction, throughput, and many more. We usually use the DMAIC approach for larger projects and PDSA, or as we refer to it, PDCA, for smaller ones. I should say my favorite thing about my job is the problem-solving aspect of it. It is truly exciting to get to work with a diverse group of people with different skill sets and backgrounds. Over my tenure here, I've gotten to know and work with hundreds of people, including doctors, nurses, respiratory therapists, ancillary support, administrators, and most importantly, LSU industrial engineering students.
And tell me more about Our Lady of the Lake Hospital.
We are part of a collaborative between LSU and Our Lady of the Lake that is called Healthcare System Engineering, HSE. As part of this collaborative, since 2017, our hospital has worked with 57 IE students on 21 different projects, which 17 of those were senior design projects and 4 were graduate level projects. We've also had 2 undergraduate interns and 4 graduate level interns over the past couple of years. So senior industrial engineering students can fulfill their capstone project, or as known as senior design project, in a healthcare topic here at Our Lady of the Lake. Each year, there are groups of 3 to 4 students that work with a faculty member from LSU and 1 member from the Lean PMO department towards their project on a real healthcare problem. As I mentioned, we've also worked with master's and PhD students like Guru on some initiatives, like the respiratory equipment and storage project that we're going to talk today. Before we get into details, I should say Guru was the main lead on this project, and my role was more of a mentor and facilitator for him.
That's great. So whenever I was at LSU as a student, we didn't have a co-op with Our Lady of the Lake. So it's fantastic that that's happening. It's really opening up healthcare to industrial and systems engineering. That's great to hear that. Can you give me an overview of the project that Guru worked on with you at Our Lady of the Lake?
Sure. So the project was focused on the retrieval process and the inventory of BiPAP equipment, which BiPAPs are a type of non-invasive ventilation for patients that have difficulty breathing. So we use a lot of BiPAPs in the hospital, and we are a large facility, and we have 3 buildings So as you can tell, it gets kind of tricky on where those equipment go and how we're going to get whenever we need another one. So as Guru worked on this project, the interventions and solutions were centered around 3 pillars. One of the pillars was visual management. So part of that was 5S. Part of that was the visual cues in the room to help the respiratory therapist know the correct power level of the BiPAP. The second intervention was the training and the proper utilization of our asset management tracking system. The one we utilize here is called Skytron. That's our vendor. That was the second intervention. And the third one was utilizing Skytron to send out automatic text messages whenever our defined thresholds for BiPAPs were violated. So we had thresholds defined for, say, the areas that the equipment is not supposed to go, or the times that an equipment stays in the hallway for a longer period of time than reasonable. And third, when an equipment enters a room and it's not supposed to be there because it's exceeding the power level that was defined for that area. So that's what we refer to as automated text messages. And as that triggers, there were subsequent tasks that needs to be done by the staff in order to address those alerts and text messages. So that's just an overview of the 3 main pillars of the solution.
You mentioned that you use the DMAIC roadmap for this project, and we see that a lot in Lean and Six Sigma methodologies. One big technique that's used in that is voice of the customer, and that's a very important first step in gathering data. How did you go about collecting the voice of the customer for this project?
So I think it's super important for an outsider when they walk into a project and they want to work with a certain area and department on their processes to have a good grasp of their processes. The thing we use a lot here at our department and also beyond our department, we refer to them as Gimbal Walks, is when you go to the actual place that work is being done and you observe those staff members that do the job. So you kind of want to see it from their eyes and see how they go about their day as it relates to that specific process that you're observing. So in this case, Guru can speak to it that he was very involved with shadowing the respiratory therapist, having multiple meetings with their leaders, trying to understand what the pain points are and what's the best way to approach those barriers. So I think one way that Guru and I went about this was using survey. We distributed surveys among respiratory therapists, trying to understand what the barriers are for them in finding and retrieving and storing their equipment. We also asked them what's working well. So we try to kind of target both. So if I want to sum this up, it was a combination of Gimbal Walks, meetings, survey that help us get that voice of customer for this work.
Guru, tell us more about yourself.
Hello, everyone. My name is Nandhaguru Durai, and I did my undergrad in aerospace engineering, and I'm graduating now this semester with my master's in industrial engineering from LSU. I got introduced to this project through HSC collaborative with LSU and Our Lady of the Lake. As mentioned by Milad, we acquired the voice of the customer through surveys and also with meetings that we had with the project leaders.
So, Guru, what were some of the concerns or problems that Our Lady of the Lake employees were voicing? And once you gather that information, what were some of the goals that you outlined in the beginning of the project?
So from the survey and the meetings, we learned that over 70% of the candidates who responded to the survey said that for them, it was BiPAP was the most challenging equipment to find. And the problem with finding the BiPAP is that it's been used all over the hospital, like from 30 to 48 patient care units, including COVID special units. The BiPAPs are spread across 3 building structures, 8 storage units, and 12 floors. So here you can see where the problem comes from, as the equipment is needed as quickly as possible, and also it's placed all over the place, and we only have 51 BiPAPs in the facility. I'll just give a quick note about the equipment itself. So BiPAP is a bi-level positive airway ventilation assist system that's mainly used for assisting patients with having difficulty breathing, and also having for conditions like heart conditions, sleep apnea, and also for COVID-19 patients.
It seems as though the BiPAPs became even more critical than before, especially with COVID. And that was something that you found from doing your Gimbal Walks. So based on also what you told me about how it's spread across different buildings and things like that, I imagine there was a lot of travel time and it's hard to track. So I know that was one of the main things that you tackled in your project was tracking the BiPAP machines. Can you talk to me more about how you did that?
Yeah, for me, when I got into this project, it took me like 2 to 3 weeks just to learn the floor, and I constantly get lost. And for me, it's hard to get lost, and it's even harder to find an equipment which is situated in a patient room. So I had to do a lot of Gimbal Walks where I went with the respiratory therapist to show me around, like where they be when like during normal shift hours, and when will they get the order for the BiPAP, and how will they go about, like where will they first check for the BiPAP, and what will be the secondary location that they will search for the BiPAP. Here at Our Lady of the Lake, there is a asset management system called Skytron, which tracks all the equipments which are with the active RFID system. So the 51 BiPAPs are monitored in the storage units, in the patient rooms, and also on the corridors outside the patient rooms. So we basically use this system to know where all the BiPAPs are. But one technical issue was that not everyone was happy with the UI of the Skytron. Only people who were like familiar with IT, they were able to log in and search for the BiPAP and locate it. Others used like lesser technical methods, like they'll just text their peers, and also they'll just call the supervisor and ask whether they saw any BiPAPs while they did the morning walks. So this presented that there is no straight way to find a BiPAP.
So as Guru mentioned, we had a system we still have a system for tracking our equipment. It's an asset management system, but it was not utilized to the extent that it was capable of. So what Guru did and what he utilized for his work, he not only found opportunities with the current system that we were having for tracking our assets, but he actually built a process behind it to support that system. Because technology by itself not going to help you 100% of the time if it's not supported by a process.
Absolutely. It's so important to make sure you integrate everything. And that's one of the big problems that we face as industrial and systems engineers, is making sure that making an improvement in one place doesn't negatively affect another. It's a very good point. So Guru, what were some of the other industrial and systems engineering techniques that you had to utilize for this improvement project?
So here we used like different tools to achieve this. Mainly we used 5S in the storage units to make it easier for the respiratory therapist to access the equipment. And we used spaghetti diagrams to understand the floor and understand how the respiratory therapists are moving inside the floors and how much distance they are traveling. And we also used process flow charts to understand different usage case for the BiPAP, and which allowed us to pinpoint where the bottlenecks were in the system.
Milad, what did your control plan entail to help sustain these changes that Guru worked on for the hospital?
Absolutely. So I think for IEs, no matter what industry they work in, it's pretty important after they work on a project, they have a good sustained plan. So once they leave, things do not fall apart, if you will. So what Guru did was put this process in place in order for the supervisor of the respiratory department to have routine audits and checks to make sure, first of all, if the text messages are happening, if given the criteria that we define in the system, if our power levels are out of control, or if an equipment enters the soil utility room, which was one of other criteria we had, or if an equipment stays in the wrong location for a certain amount of time, the supervisor would make sure those texts are happening. And on the back end, someone is reacting to those texts. Then again, technology by itself would only do so much. It needed to be backed up by a process. In this case, the supervisor would make sure that moving on would make sure that things are working, people are reacting. And if for any reason, any of the signals was not working, because that's a possibility, they have a plan how to address it, how they reach out to the right resource to fix those. So before Guru hands over this project, we met with the supervisor team and their leaders to make sure they have a good understanding of what's been done and what the expectation is to sustain the work. And I think everyone was very receptive and very grateful of the work that was done with their area. So that's those are some elements that he used in the sustained plan.
I also love how, thinking about Plan, Do, Check, Act and all these models that we use, how you always have this feedback loop. And when you get to the sustain part, you know, the philosophy is the project's not over, right? It's working towards keeping those changes in place, but also to continually improve. So we have this feedback loop in everything that we do. That way, it's not just a snapshot in time of, oh, we made these improvements and that's it. You know, that's the end of the story. And as we all know, that's not how it works. And we always need to work to continually improve whatever systems we put in place as well. Because as you mentioned, there are times where, oh, this doesn't work out as good in practice as I thought it would in theory.
I agree. And there are times that the solution is awesome. The team works so hard towards that solution. Everyone is happy. But if a solid sustained plan is not in place, things could go in the wrong direction soon after that facilitator or project lead leaves that area and no longer works with that area. So that's one thing we always make sure that we have a good plan of sustainment before we hand off the project.
And another big part of that too is making sure that your process is strong and that you're not relying on the people, because people aren't always going to be a part of the process. So you want to make sure that your process is sustainable. It's the word of the day.
Absolutely. They go hand in hand. People and processes, they go hand in hand. You can't have one without the other.
Exactly. Guru, what were some of the impacts your project had on the hospital? I know that a big thing was search time was reduced significantly, and you also improved utilization. Can you go into more detail into some of those metrics?
Yeah, for the start of the project, we had a goal to basically reduce the search time of the BiPAP by 50%, and also to develop a standard operating procedure for the respiratory therapist and how they would go about finding the BiPAP and store it back in the storage units. So in order to achieve these time reductions, we implemented two solutions. One is the text alert system and the fibers in the storage units. So the text alert system helped us locate the BiPAP and send a text alert to the supervisor, whether the BiPAP is outside the patient room waiting for somebody to pick it up, or the storage unit is so that it has more BiPAPs than it's allocated for, or it has less BiPAPs than it's allocated for. So this text alerts made sure that the power levels in the storage units is maintained and not a lot of BiPAPs are left unused in the floors. So we used 5S in the storage units where we placed floor tapes marking the location of the BiPAPs according to the power levels of each storage units, and also visual indicators in the line of field where they can see when they open the door from the respiratory therapist perspective. There will be a poster mentioning how much BiPAP should be here, and if the BiPAP is more than what it's supposed to be, where it should be taken. And this helped them maintain the power levels in the storage units.
That's fantastic. It's always gratifying when you get to the end of the project and you get to relook at the data and see the improvements you made. So that's very impressive. And I'm sure Our Lady of the Lake is very appreciative of all the improvement efforts that you made in this project, and that Milad has worked with students over the years to help out with the hospital in that way. So speaking of that, Milad, were there any other applications you saw this having an impact on in the hospital?
Although the project was focusing on one equipment type, which was BiPAP, as a result of the work and the project and the training that the respiratory therapists received, they learned how to work efficiently and effectively with our asset management system, our tracking system. So not only now they know how to work with it to find a BiPAP if they are looking to see where is the next available BiPAP laying around, they can also use the system for other types of respiratory equipment. Also, on a broader level, there is a growth opportunity that we here within the Lean PMO team is currently discovering to expand the work that Guru did to other movable medical equipment. You could imagine having 30 plus units and hundreds of patients and several rows across the hospital makes it a bit challenging for certain shareable movable equipment that travel from one area to another. So the staff can have a smoother process for retrieval and storage of other movable equipment.
As you were saying that, I was thinking, how can I apply this to where I work? Retrieval and storage of movable equipment is always a big issue. And the amount of non-value added time that you get from doing a time study or however you gather information, I'm always shocked by how much time is spent looking for equipment. It's always much, much higher than I anticipate. So yes, as you were talking, I was thinking, this sounds like something I could use where I work, even though my background is in manufacturing and not healthcare. So it is really neat to be able to get all these ideas and see it, cross over into other industries as well. It doesn't have to just be limited to healthcare. It can go to many different other industries. Guru, I see that you started this project in late 2020 and wrapped it up in 2021. How did COVID affect data collection and interacting with the staff at the hospital?
So with the COVID, I started with the project when the COVID season was high, and we were able to collect that data, like the high season data that we referred. So we were able to check if we had enough BiPAPs and how much COVID patients are using the BiPAPs and how much BiPAPs are allocated to other patients. And because of COVID, we were unable to physically go with the respiratory therapist and collect their time because of safety reasons. So we had to develop a manual simulation to collect the search time, where by myself act as a respiratory therapist, take the BiPAP orders from the system and go looking for a BiPAP in that floor and time that time it took for me to find a BiPAP and bring it back to the patient's room. And that's how we were able to collect the data and find the closest to possible data collection that we could be done in this COVID situation.
So yeah, as Guru was mentioning, at times it was hard to shadow the respiratory therapists because they were going to COVID units, they were traveling around the hospital. So what he did was he used a tag, and then he would carry this tag around with him as if this is a real BiPAP device. So he would walk those floors and kind of simulate in a manual fashion on how would that equipment flow in the hospital. So in lieu of not being able to shadow the respiratory therapist as often as he wanted to, he was able to use a tag and move that tag with him across the hospital in order to get some of those time studies done, some data for his spaghetti map and stuff like that.
It's great that we can leverage technology in a time like this, because I can definitely see how working in a hospital during COVID, obviously that has its own set of difficulties, and not being able to do the Gimbal Walks and things like that, like you normally would be able to. So it's great that y'all found a way to still simulate that.
Yeah. Also, the other thing was, as this was happening during COVID, we've been in COVID for some time now, there were times that his meetings would cancel with those leaders over the respiratory department. And then he had to work on some other processes in the meantime and not wait on that element or item that he needed their clarification, instead work on some other processes and not wait for that. So he had kind of to readjust, like many of us that we've been working in the hospital in the support services department, because we don't deliver direct patient care. So he kind of learned it as he was doing this project, that he had to be flexible and work around the schedule of people who were all of a sudden super busy and needed to be in other meetings and not necessarily in an improvement meeting.
Yeah, definitely. Over this past, I keep wanting to say year, but it's now been a year and a half going on too. The name of the game has been flexibility and adaptability. We've all had to make adjustments to how we would normally go about doing things. And for industrial engineering, gathering data is one of those things that we all had to learn different ways to go about getting that, so that we can still continue with our improvement projects and things of that nature. Milad, where do you see industrial and systems engineers having the most impact in healthcare?
I think with healthcare, as it's growing and growing, there is always this urgency to look for ways to be more efficient and cut unnecessary costs, any types of waste that we are pretty familiar with as IEs. So it's hard to pinpoint to a certain area. I think overall, in optimizing the healthcare, IEs can help a lot with that. And I think it's because of the out-the-box thinking that an IE person has, that they can be this outsider that suddenly is working with our surgeons, our leaders, our nurses, and see what they are doing with each of those processes that they are there to help improve. And as you know, as IEs, we learn system design, we learn how to run simulations, we learn about ergonomics. And I think that a skill set enables an IE to be successful and make contribution, actually good contribution to healthcare value delivery.
Guru, what was your favorite part about working in the hospital for this project? Where did you feel you learned the most?
My favorite part was like the daily Gimbal Walks that I did. And it helped me like see how the process works and how the hospital functions as it is. And the COVID presented a challenging space for everybody. And I could see that this project had a good impact, with the respiratory department and also benefiting the hospital and the patients.
Do y'all have any lessons learned or advice that you'd like to share with those starting on projects similar to this one?
I think with this project, the team really enjoyed working with Guru. He was new to healthcare with no prior healthcare experience. Sorry, I'm going to do it again. I think with this project, the team really enjoyed working with Guru. He did not have any prior healthcare experience. As he mentioned, his background is aerospace in undergrad and then IE at a master level. So I think one advice that I can give is with this project, what he did, he worked very closely with the process owners and with those people who were actually doing the work. So he engaged them often and early on. So it wasn't like he would go about his work and then he comes with some, say, unrealistic expectation for the team to do. He would work with the team to come up with the right process, with the right solution. He almost, at times, he was making them to make the calls and determine what's the correct power level based on the data that he had analyzed. So I think engaging process owners, engaging people who do the work, certainly going to contribute to the success of any work, especially times like this that everyone's super busy, especially in healthcare, and they need to be aware of that win-win situation. So with this work, Guru was able to gain experience, work towards his master's project, and also he delivered a good outcome and good product for our hospital by doing this project. So I think, as I said, engaging the people who do the work is super important. And I would advise that to anyone who is working with people in healthcare on a lean project.
Guru, do you have any lessons learned that you'd like to share with our listeners today?
As a graduate student, I would like to tell that whoever is looking to take on a project and doing it, I would like them to understand the process first. For me, since it was a hospital, it was a very different environment than what I used to think as an engineer with machines and everything. Here we have to work with the people, and that's the one advice I would like to give. It's more of a people-oriented process, so we have to learn how to adjust with them and how to make them understand our side of the industrial experience and make them to apply the same skills that we know that will work. One more thing that I learned is that to look beyond what the system is doing. So in case of the asset management system, the Skytron, so I was looking into what are the options available with the system provider, and found out that they had an alert system that was not utilized in the facility. And I contacted the service provider, and he was able to give me information like, will the equipment be tracked? Will we be able to set certain areas where it shouldn't enter, and will that trigger a alert message? And all this were only possible as I was looking outside the current system's capability and was able to find this solution, which was very helpful in bringing down the BiPAP search time.
Milad and Guru, thank you so much for sharing your work and for showing us different applications of industrial and systems engineering in healthcare. And thank you to our listeners for joining us today. We hope you enjoyed it.
All right. Thanks for having me.
Thanks for having me as well.
Thanks for listening to this episode of Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Metro Atlanta. This podcast is produced by David Brandt, Keith Albertson, and Michael Hughes, and edited by David Brandt. You can listen to all episodes of Problem Solved and learn about sponsorship opportunities by visiting our website, podcast.iise.org. You can also learn more about IISE at the Institute's website, www.iise.org.